Good day everyone! So for today, I will be sharing with you my technique on how I deal with trigonometric identities when I was studying. I hope for those who are reviewing now on trigonometric identities, please stay with me and I hope this lesson will help you. Yalla, let's go! So I don't usually memorize trigonometric identities because we have so much of them. What I usually do is I always go back to the basic. And the basic foundation of trigonometric identities is our Pythagorean Theorem. So just to have a quick review of the Pythagorean Theorem, say if this is your right triangle, and then it says like you have the hypotenuse here and the altitude and the base, we say that c squared is equal to a squared plus b squared, right? And then if you have a reference angle there, so if you want to get the sine, okay, of that angle, it will be like sine is SOHCAHTOA opposite over hypotenuse, which is a over c, and then cosine of that angle is adjacent over hypotenuse, which is b over c. And then we have also tangent of our reference angle. We have TOA opposite over adjacent, which is a over b. So now, using this basic knowledge, we can derive as much as trigonometric identities as we can. So we say that c squared is equal to a squared plus b squared. So c squared is equal to a squared plus b squared. Now, if I will try to divide all terms by c squared, okay, you will see now that you have c squared over c squared, you have 1 here, and a squared over c squared plus b squared over c squared. So we know for a fact that a over c is sine, right? Sine here. A over c is sine. So therefore, if you have a squared over c squared, that is sine squared. So 1 is equal to sine squared plus b over c is this one, cosine, right? Cosine is equal to b over c. So if you try to square that, you'll have cosine squared. So that is one trigonometric identities. Or from this, you can try to play with this equation. You can have sine squared is equal now to 1 minus cosine squared. So this is another identity. Or the other way around, cosine squared is equal to 1 minus sine squared. So again, that's another identity. So going back again to our Pythagorean theorem, so let's say you have c squared is equal to a squared plus b squared. So this time we will try to divide all terms by a squared. A squared, then a squared. Okay? So what do we have now? So c squared over a squared. So that means that's the opposite here. So this is a over c. C over a is cosecant, right? Cosecant is c over a. That's the reciprocal of sine. So therefore, if you have c squared over a squared, that is cosecant squared, is equal now to 1, right? Plus, okay, what do we have here? B squared over a squared. So that's the reciprocal of tangent. So the reciprocal of tangent is cotangent, which is b over a. So you have square here, you have cotangent squared. So this is another identity. Or you can have it like cotangent squared is equal to cosecant squared minus 1, which is another identity, right? Or what you can do is cosecant squared minus cotangent squared is also equal to 1. So this is another identity. So again, from the basic, you have c squared is equal to a squared plus b squared. So this time, we will try to divide all terms by b squared. B squared, b squared. So we say that c squared over b squared, that is, you have here cosine is equal to b over c. So that is second now, theta is equal to c over b, which is the reciprocal of cosine. So therefore, you have here second squared is equal now to a over b. It's what? Tangent, right? So tangent squared plus 1. So this is another identity. Or you can have it like tangent squared is equal to second squared minus 1. That's another one. Or the last one would be second squared minus tangent squared is equal to 1. So that's another identity. Okay? So that's our quick lesson for today. And one thing for sure, we will solve more problems, board exam problems on trigonometric identities using our lesson for today. I hope you like the video, and don't forget to hit the notification bell, subscribe of course, and see you on our succeeding videos. Until next time guys, bye-bye!